design tip on how to create gears in SolidWorks. Very fast. File, new, assembly. Okay, how to create gears in SolidWorks without sketching. Very fast. So you get an assembly file. Go to assembly file. From assembly file, I want to show you how to create a gear in SolidWorks without sketching. So we are on assembly. Just click this one, then come to this. We call it a design library. Then ensure that you click on this toolbox. Click add now. Let it add a toolbox. Expand this toolbox. Go to ISO. Then go to power. Go to gears. And then this we have helical gear. We have internal spur gear. You have rack and pinion. We have spur gear. We have that is external spur gear, bevel gear, and then we have the straight meter gear, and also straight bevel gear or gear and pinion. So I want to get a simple gear. So drag on this, hold it in, then drag on it to the window. Once it comes to the graphic window where you are drawing it, you now input your spur gear is normally defined by the PC, that is the pitch diameter, number of teeth and modules. So if you pick the modules here, these are the modules. You can pick the modules one. For example, if I pick a module of 1.25, this will determine the shape of the gear. Then, for example, if you pick a module of 1.75, it determines the shape of the gear. And then this is the face width. The face width is normally 12. So you have a face width of 12. You can put the size of the gear you want for the face width. And then pressure angle, normally two of them. Normally when designing gears, you can either use 14.5 or 20. I'm using 20. The number of teeth, you can now put number of teeth. For example, I want this one to be driver. I can put maybe 32, for example. And then you can go to the hub. For example, this one, number of internal diameter, maybe I want to put it to be 20. You see, it detects, and then is what you call this is the internal diameter, and then you have what you call the square, type 2 square, and then you have type 1 square. That is for keyway, or you can put none. If you put none, it doesn't come on, you see. So if you want to have a keyway, type 1 keyway, you can put that. And then here you have a hub. Which kind of a hub? For example, I can say type B. Type A, it is flat. Yes. Type B, it is on one side. Type C is on both sides. Type C is on both sides. So maybe on both sides, it's going to hub diameter, which is too big. I can put it maybe to that 40. Even 40 is too big. For example, 35. Betting on what you are designing, I can put this one. Sorry, and this one 35. Therefore, over the length of this hub, both sides it calculates cells, so I can put 20, for example, so that you don't put a big hub. You see, so this is how you can design gears in SolidWorks. So we have designed one type. So you can click on this, okay. Then click on this, okay. You can right click this one. You can say maybe, for example, front, this and this, and this. Then come to axis, pick axis, then click OK. But ensure that this one is you right click, then you say float, so that this axis, and this center, you see, and this center, you can come here, you can place this gear anywhere you want, and then you can come here, this one, then say I want to mate this one using concentric with this hole, like that. Then you click OK. Okay. You can also show the origin, this origin. You can say mate, and then maybe you can pick advanced. You say with mate, or this mate, or the standard way of mating. Then you can say I want to mate on this face, origin on this face, and click OK. Okay. So you have put this gear. As you can see, the gear is able to move. Yes. How can we know the PCB of this? The pitch diameter. So pitch diameter is very simple. You take the number of teeth, that's module. Our module was 1.75. Our module was 1.75, and number of teeth was 32. So what is the pitch diameter? Pitch circle diameter. Pitch circle diameter. So you take the 1.75 as the module times number of teeth 32. You get a pitch circle diameter of 30 or 56. We want to add another gear of the same module. Yes, of the same module. So you drag it, same module, but number of teeth I want to increase to be 64. So I want to put it 64. 64. You see, pressure angle is 12. This is 12. Then I go to this type C. This one I put 35. Was it 40 or 35? Depending on how I want it. And then this one I put 35. Is it? This one I put 35. Sorry, 20. This one was 35. This one was 35. Then this was 20. I want to make it the same. Then pressure angle I'm using the same. The hub, this nominal diameter I had put 20. Nominal diameter was 20. Then we had type for keyway we had type A, square 1. And you can see the number of number of teeth is 64. So the second PCB, first PCB is 56. Second is to take times 64. So you are getting 112. So click OK. Okay. And then cancel this. Click this one. Ensure that you float this one, this gear. You can float it. Already it's floated. So what do? We want to make this one now. But there's something I want to I'll show you. So click on this face first of all. Move this somewhere. For example, click on this face, and then sketch. This we have a PCB. For example, if I sketch on this center, and then another circle. The gears normally made using pitch circle diameter. So I can say this diameter is 56 because I'm using the pitch circle diameter. And then this diameter should be 112. Remember, I'm using the module times number of teeth. So it gives me the module of this. Then how do I get the center distance between the gears? So center distance will be very simple. I can use this circle and this circle as tangent, or I can take 56 plus 112 divided by 2. I get 84. So I can say I can do a simple straight line from this point up to this point, and then I say this one is horizontal. Then I say this is 84. You will see it must touch. I can say this is 84. 84. You see it is touching. Then I can exit. So this is the circle diameter for this. So what do? I can now say from this point I'm able to create an axis. Like come here axis, and then maybe use a point like this. I can get an axis there. But what do? I want to make sure that I can drag this here, and then I say this face, this circle, say mate, it must be concentric with this one, is it? It must be concentric. And then this face and this point here, I want to make it, for example, I can remove this one, this face, and this point here. I want to make it coincident like this. Yes. Then you see, if I'm able to move, this is free. This is also free. So I can hide the sketch. I can say this is for the pitch circle diameters. Pitch circle diameters. Enter. Then I can hide them. Hide these sketches. Then I can click 1, 2, 3, like that, 4. So I have this one and have this. Yes, as you can see, this one is free to move. If you click on it, it can move. If you click on this, it can move. Now, how do I mate so that they are able to move? So what do? I click on this one, then click on this face, then say normal. Then manually drag one gear to at least to be inside. The other one, or to mesh like this, for example, like this. Yes, for example, like this. And then come to mate, Control 7. Which one is the driver? The first one you pick is the driver. The second one you pick is driven. Come to mechanical, then click on gear. Then I want to use the gear ratio, so I can pick on this gear. For example, this is where it is mating. I can pick on this gear, and then pick on this gear, the two of them. So the first one, I'm using a ratio of, I want to use PCD. I can use a PCD of, let's say, 32, diameter 32. Then second is the diameter, this one I can say it should be the diameter 56. This is diameter 112. I can use PCD 112, but let me use the 32 and 64. If I click OK, Control 7. If I rotate this, it must rotate the other one. If I rotate this one, it must rotate the other one. So if one gear goes clockwise, for example, if this one goes clockwise, like this, Control 4. If this one goes clockwise, let me put it clockwise, like this, the other one goes anti-clockwise. If this one goes anti-clockwise, the other one goes clockwise. So this is how you can mate gears in SolidWorks. Very simple. You can design gears in SolidWorks and then mate gears in SolidWorks. So we have used Spur Gear to do mate. Then you can even put a simple motion analysis, a simple animation. You can put a simple animation. Maybe you put a simple gear here. You can say from this face, it's going clockwise. Component rotating to do maybe this one. You can put maybe at even to 1. For example, I want to just put symbol. Then you click OK. Then you click here, calculate. You can see when one is going clockwise, the other one is going anti-clockwise. This is a very simple way of designing gears. When the other one goes anti-clockwise, the other one goes clockwise. Very simple way of designing our gears. You can put maybe this one, then calculate. When the one that goes clockwise, the other one goes anti-clockwise. You see? Very simple way of designing gears in SolidWorks. Thank you and have a lovely day.